So I have given you a graph of y equals f of x. We are going to use this graph to sketch the graph of y equals f prime of x. Okay, so first thing I want you to remember is f prime of x is the derivative, and the derivative is going to be the slope of the tangent line of f. That's a really important thing to remember. So let's go ahead and look at this graph right here. I am going to start with the easiest ones, and the easiest ones are going to be where you have a local maximum and a local minimum. So for example, here at x equals 1, that is a local minimum. If you were to draw the tangent line there, it would look like this. It would be a horizontal line. Actually, right there, the tangent line would have a slope of 0. The same thing is going to happen if you have a local maximum. You get m equals 0. Or another local minimum right here. It looks like it's about 4.3 or so. So at those points, your derivative is going to be equal to 0. Slope of the tangent line is 0. So we know at least 3 points on our derivative graph. I'm going to tell you right now, actually, the y values on the f graph do not matter. We do not care what those y values are. If this entire graph of f was shifted up or down, it would still have the same derivative graph. So please keep that in mind. We do not care about the y values on the f graph. We do actually care about the x values, however. So what we're going to do, I'm going to start when x equals 1. So when x equals 1, we're going to draw a corresponding point on our graph of the derivative. So we know when x equals 1, my derivative is going to be equal to 0. And then the same thing happens at x equals 3 and at x equals whatever this one is here, about 4.3, 4.5-ish. So those are the things that we know there. The next thing that we can do is we can, when you just have a picture, it's really hard to estimate the derivative. So don't try to be perfect on this. You can kind of look at, well, first of all, you can look and see what's negative. You can look and see what's positive. And you can see that some places are steeper than others. So let's start at x equals 2. At this point right here, you might disagree or you might agree, but I think that that one looks like the slope is approximately equal to 1. We do know that it's positive, which is helpful. X equals 4. That one is pretty steep and it's negative. I'm going to say that that one maybe is, that's not a good tangent line. Just having trouble getting a good tangent line. To me, that looks like it's approximately equal to -2. You might disagree with me, but I think it's about -2. So I'm going to put in m equals -2 for that one. And then at 5, to me, that looks like it's about +2. Make sure you get your positives and negatives correct at least. So let's go ahead and draw those 3 points. So at x equals 2, we established that we thought m was equal to 1. At x equals 4, it looks like it's about -2. And at x equals 5, it looks like it's about +2. So when I draw this, this is not going to be perfect, by the way. It's going to be kind of like that. Try to draw it kind of curved. You'll notice that the part I have around 4, it looks a little bit off. I'm actually going to try to fix that a little bit, make it look a little bit better. So the last part I should probably try to figure out what's going on at x equals 0. To me, it looks like that is about -2. Again, we're not going to get it perfect when we're just looking at a picture. So I'm just going to kind of take a guess, but I think it's about -2. Once you get those points, you're just going to kind of connect the dots between them, like I just did before. The one other thing is when we are a little bit more, when we get to the negative numbers, it looks like it's a little bit steeper than it was when x was equal to 0, which means that it would become more negative. So I'm going to go ahead and I'm just going to go straight down. I'm going to stop there though. I don't actually have any more of the graph other than what's shown, so don't draw anything extra. So this is my approximation of f prime of x, my derivative.